Imagine everything you thought you knew about the universe. Completely changed now. For decades, two invisible giants have dominated our cosmic understanding. These are dark matter and the dark energy. They are the fundamental unseen force we have used to explain almost everything, from how galaxy spins to why universe is expanding. But what if I told you that these two giants might not exist at all? What if they are just an illusion, a side effect of something far more fundamental? So, friends, get ready because this revolutionary new theory is challenging everything and it could literally rewrite cosmology as we know it. To understand why this new theory is such a game changer, we first need to grasp what dark matter and dark energies are and what they are supposed to be doing. Let's look at dark matter first. Think of it like this. When astronomers look at the galaxy, they spin incredibly fast. So fast, in fact, that the visible stars and the gas alone don't have enough gravitational pull to hold the galaxies together. It should just fly apart. To solve this, scientists propose a dark matter, an invisible substance that doesn't interact with light but has an immense gravitational pull acting like a cosmic glue. It's thought to make up about 27% of the universe's mass energy content. We can't see it, we can't touch it, but we infer its existence from the gravitational effects. Now, let's come to dark energy. Fast forward to the late 90s, scientists observed that the expansion of the universe isn't just happening, it is accelerating. This was a monumental discovery. To explain this mysterious push, they introduced dark energy, a repulsive force inherent to the space itself, as essentially pushing everything apart. It's even more dominant, making up to about 68% of the universe. So together, dark matter and dark energy accounts for whooping 95% of our universe, and we only understand 5% of it. The stuff we actually see and interact with. This has been a prevailing model for decades. While these concepts have been incredibly successful at explaining observations, there is a huge catch. We have never directly detected either of them. Despite massive efforts, multi-billion-dollar experiments underground and in space have found no definitive particles of dark matter, and dark energy therefore remains an abstract concept without any tangible source. This lack of direct evidence has led some brilliant mind to ask provocative questions. What if we are wrong? What if we have been trying to fit square pegs into a round hole? What if the effect we attribute to dark matter and dark energy are actually manifestation of something else entirely? This isn't about throwing out decades of science. It's about re-evaluating the foundational assumptions. The universe works in a mysterious way, and sometimes the simplest explanation isn't the most obvious one. This brings us to the core of our discussion today. A new theoretical model recently published and gaining significant attention proposes a radical idea. Dark matter and dark energy may not be the separate mysterious entities at all. Instead, they could be side effects of changing forces in the universe. Imagine the fundamental forces that govern everything. Things like gravity, electromagnetism, strong and weak nuclear forces. What if, instead of being constant throughout the universe's history and across all the cosmic scale, these forces subtly changes? This model suggests that the strength or the behavior of these forces isn't uniform. On the vast intergalactical scale, where dark matter influence is seen, perhaps gravity itself behaves slightly differently than we observe in our solar system. Similarly, the vacuum energy, the inherent energy of the empty space, often linked to dark energy, might not be static but dynamically changing with the evolution of the cosmos. Think of it like this: if you are trying to figure out why a car is swerving, you could invent an invisible giant pushing it, or you could realize that the road itself is subtly curving. This theory is like realizing the road, the fabric of space time, and its fundamental interaction is changing. This isn't about inventing new particles or exotic forms of energy, it's about more nuanced understanding of the forces we already know, and we know that they exist. By allowing these forces to evolve or vary under certain cosmic conditions, this theory potentially provides a unified explanation for both the missing mass problem, which is related to dark matter, and accelerating expansion problem, which is related to dark energy. If this new theory holds up, the implications are absolutely profound. A simpler universe. It means we might live in a universe governed by fewer, more elegant, interconnected principles, rather than needing to invent two entirely new elusive components that makes up 90% or 95% of the reality. The unified explanation, therefore, is instead of two separate mysteries, we have one grand framework that potentially explains both. This is the holy grail of physicists, finding a single theory that ties together seemingly separate phenomena. This model could lead to deeper understanding of the gravity itself, perhaps even hinting at how it connects with our other fundamental forces, a step towards a theory of everything. Instead of just searching for dark matter particles, scientists would shift focus to precisely measuring and understanding the variation in fundamental forces across the cosmic scales and throughout the cosmic time. This opens up entirely new experimental and observational program. It is important to note that this is a theoretical model. It is published, it is gaining traction, and it is backed by rigorous mathematics. But like all scientific theories, it needs to be tested, scrutinized, and either confirmed by new observations or modified, or even superseded by something better. This is the beauty of scientific process. So what does this mean for the future of cosmology? The next step involves making testable predictions. If gravity truly varies in different scales, can we design experiments or observations that detect these subtle changes? Can we use new telescopes and gravitational wave detectors to find signatures of these changing forces? Expect robust debate within scientific community. Established theories like dark matter and dark energy have decades of evidence supporting them, and challenging them requires overwhelming proof. This intellectual sparring is exactly how science progresses. Regardless of whether this specific theory becomes dominant model, it represents a crucial shift in perspective. It forces us to reconsider our assumptions and explore alternative explanations for the cosmic phenomena we observe. It reminds us that our understanding of the universe is always evolving, always subject to revisions as new data and new ideas emerges. The universe is far from intricate and surprising than we even often imagine. The idea that the dark matter and the dark energy, these titanic mysterious components, could simply be emergent properties of the forces we already know, and there is nothing short of mind blowing. It's a testament to human curiosity and ingenuity that we continue to provide these ultimate questions. Whether this theory ultimately rewrites our textbooks or simply open up new avenues of thoughts, one thing is clear: the quest to understand our cosmos is far from over. So, friends, what are your thoughts on this revolutionary new idea? Let me know in the comments below. And if you found this discussion as fascinating as we did, please hit that like button, share this video, and subscribe for more deep dives into the mysteries of the universe. Thank you for joining live. Thank you for watching, and I will see you in the next cosmic journey. Until next time, bye for now.